Right. So today we'll quickly finish up this topic uh, for the lab assignment. So in the theory part, theory sessions, we have seen these primitives, TCP socket primitives, uh, and also we have discussed this part, how the client program and server program should behave, or what kind of functions they should be executing. So what I'll do is I'll quickly revise this diagram, and then we'll go to the program itself. So uh, first let us talk about the server program. So we are talking about the top socket programming, where we the two machines are completely different. One is client and other one is server, and you are writing the programs, two different programs for two different machines. So let's say what server program should do. It should create a socket with the socket function. Uh, so once you create the socket descriptor will be created if there is no error. Then using that socket descriptor, you have to bind that socket with the IP address. So bind function should be executed by the server. And these functions has to be executed in this sequence only. Okay, you can't execute bind function before socket function. So so next is bind function. Once the binding is done between the port and the IP address, then server should execute listen function, so that it can listen to all the connection requests sent by any client, any number of clients. So so here server passively waits for the connection request. Okay. Now, if suppose there is a client who is trying to send a connection request, how does it will happen? So client should also use socket function to create the socket, and then it directly calls the connect function. Okay. Now, once it executes connect function, the connection request goes to the server, because in the connection connect function, you are mentioning the server's IP address, so that it will this connection request automatically reaches this program, uh, because this program you have mentioned the port address and all these things. So automatically the request reaches at this server program. Once the server request is reached here, server executes accept function, and once this request is accepted, then both of them can send and receive the data. Okay. So now write function can be given by the like executed by the client first, and then the request, whatever the question, whatever the information is there, it will be read by the server. And if there is any response to be given to the client, the server will write the data into the socket of client, and on the same socket client will read the data. Okay. So and if the operations are done, then you can close the connection. So this is what a simple sequence of both the programs uh, you should be uh, executing that in a program. So actually this is not the program that you are going to use, because this contains multi-threading. Okay. You don't have to work with the multi-threading option in the program, but let me explain you my program, and you can just use the basic functionality of this program uh, while you are writing the program. So I'll give the different assignment for the batch A1 and A2, and different assignment for batch A3 and A4. So, so first, what you have to do is you have to include all the libraries, socket.h, internet.h, and whatnot. So pthread is an option. You can, what you can do is, I'll explain this program. If you want to see how the multi-threading works, then you can use this. Okay. So this is a thread function uh, which has to be given to each thread. Okay, so I'll talk about the thread bit later. First, let me explain you what is the program. So I hope you know what is ARGC and ARGV. Uh, do I need to re-explain this part? Is anyone, please?
So argument comes and argument values.
Okay, but uh, consider that you are creating a executable file for this one, and while executing the executable file, you you may provide some arguments, command line arguments, so that will be collected over here. So this will be the count of those arguments, and this will be the array where actual arguments are stored. So now here, what we are doing is we want to define the descriptors, integer value, because after the socket function, you get the descriptor as a return value. It's an integer value. So we are defining that. Then some variables, pointer variables, some integer variables. Then, as you remember, there is a structure that we have seen, sock addr underscore n. So that structure is already defined in the socket.h file, and the server program defines two different variables. One is server and one is client. So I'll explain you why we need two variables in the server program. So first job of the server is to execute socket function, as simple as that. So for the socket function, we need three arguments. First one is address family, and you have to use this keyword as it is because it is already defined in the socket.h. Okay. And what does it mean? It is the what kind of address family you are using. So we are using IP addressing. So internet inet is representing IP addressing, and AF underscore inet is address family of type IP. The second one is this is the program for TCP sockets. Okay, so for the TCP socket, we have to use sock underscore stream. If it was UDP socket, you have to use sock underscore dgram. And if you're not sure which type of socket you are using, so you can use sock underscore raw. So raw socket you can use directly. So, but this time we know that it is a TCP socket program, so we are mentioning this. And the third one is automatically it will decide which protocol to be used. So in this case, TCP will be used by default if we are mentioning 0. Okay, so once this is successful, automatically the socket descriptor, that is a just like a file descriptor, will be assigned. Okay, will be returned as this function. Now, if it is some negative value, then you can print the error. Okay, otherwise the socket is created. So now we have to prepare the socket ADDR structure. Okay, so if you remember, there are 5 variables which were defined in the socket ADDR, but we are using only 3 of them here. Okay, so we are not using 2 of them. So but these 3 are very important and necessary for the socket ADDR. So first one is which type of addressing family you are using. It is the same one, AF underscore INET. Now remember, this is a server address. Okay. And in this server address, what we are doing is we want to allow any number of client IP addresses to communicate with the server. So what we are doing is for the IP address that we have to define in the structure, we are providing this variable in addr underscore any. So that means what? Any IP address can communicate with the server. Okay. So uh, with this, what will happen is, suppose this is the server and there are thousands of clients who wants to communicate with the server. So the server is not restricting any client to communicate with itself. Okay. If you want to create like filters, like some of the clients can contact with you, then you can define that allowable IP address range here. Okay. But here what we are doing is any IP address can communicate with the server. Then what is the server port which we are uh, defining? Because for any program which is getting executed on a machine, that should be defining as a that should define its port address. If it is a network program, okay, talking to someone else outside the machine. So here we are specifying this port address. Okay. But this port address we cannot specify directly. Okay. We have to convert it into a network short. So the network short is the data type which is used for the port addresses. So this is the function host h2ns. The function is host to network short. Okay. So this will convert this integer value into a network short data type. Okay, which is needed for the port address. Now, port address data types are defined in the inet.h. You can see those header files if you want. So this will define uh, the values to the structure variables. Okay, now this structure is very uh, important because this needs to be passed in the bind function. Okay, so the next one is after socket function, the next function is bind function in the server that has to be executed. So what are the arguments for bind function? First one is socket descriptor, which you have got from the socket function. The second one is the variable, this server variable. Okay. Now the server variable is a simple structure variable. Okay, simple structure variable. But while passing it to the bind function, it has to be passed as a pointer variable. Okay, so that's why we are typecasting this into the sock addr structure. Uh, so we are passing the reference address of this variable, and then we are converting it into a pointer variable. Okay, so the second argument is this structure, and then the third one is the what is the size of the socket structure that is defined. So you just take a size of function and provide the server variable, and it will calculate the actual size. uh, the option for this one is there is already a variable in this structure length, that also you can use as a third argument. Now if the whole function executes properly, then there will not be any error. But if it returns negative value, then there is a binding error. So just this is just a error handling that you have to do. Next function is listen function. Server should go into listen mode. Okay. uh, so listen function is very simple. you have to just provide what socket, on what socket the server is listening. So we are providing the socket descriptor, and how many clients at a time can communicate with the server. So we are saying that 3 clients can communicate with the server. Okay, and then you can print the. I'm sorry, this is just a printed twice, but you can just print that you're waiting for incoming connection. Okay. Now, we are just defining this C variable with the length of the socket. Okay, size of the socket at ADDR, whatever the structure size is, that will be necessary for the accept function. Okay, so in the let's say after the listen function, server goes into listen mode, and let's say on some other machine there is a client program which we haven't seen yet. That client program is trying to uh, connect with the server, and consider that connection request is reached. Okay, now what you have to do is you have to accept, the server has to accept that request. Okay, now the accept, what does the accept function do? It takes the first argument as socket descriptor, and in the second argument we are receiving the information from the client's structure. Okay, so there are two structures that server has to handle. One is the server and another one is client. So server, you are providing all the details for the bind function. Okay, but for the client you don't have these details. Okay, the server doesn't have these details with the uh, from which client you are getting the request and all these things. So what happens is client also defines, whenever, let's say, let me go to the client, this is a client program. Okay, so client also is preparing this socket structure, right? And in the connect function it provides this information, right? So that information has to be collected by the server. Okay, and for that you have to provide the similar variable, structure variable, so that you can receive all the information in this variable. Okay, so uh, so just we are providing the reference address of the client variable, okay, which was defined here. Okay, we are not declaring this variable, we are not assigning uh, any values to this variable. We are just using this variable for collecting the information from the client, okay, while accepting, while server is accepting. And the third one is the length of the structure. Okay, so we want the length of this structure to be received into the uh, C value. Okay, C just an integer value. Okay, sorry. So this is the accept function. Okay, and whenever you are accepting any client's request, that uh, descriptor is completely different. So we are storing it into client stock. Okay, now once we have received this information, then it actually goes into multi-threading. But I'll explain you this part a bit later. What you have to do is, if we after accept, what we have to do is we just have to read and write, do the read and write project. Okay, so whatever the client is sending data, you just have to receive. Okay, so after the accept function, you just ignore this part. I'll explain it you in a while. Okay, and what you have to do is, here we are receiving the data from the client. Okay, so receive function is there for reading the data. You can also use a read function for that. There are multiple options, receive function or read function, that you can use. What it does, it takes the First argument is from which socket you are reading. So it is the socket descriptor. Okay. Then the second argument is it's a character array client message. Okay. Whatever the client has sent, it will be received in this variable. Okay. How many characters, maximum characters you want to receive at a time? So you are specifying that as 2000. Okay. And the zero, I don't remember zero. Right. Let me show you something. So I'm just trying to find out what is receive function. Yeah, it is just a set of flags. How this receive function works. Okay, and you have to provide zero value for all the default flags. Okay, so yeah. So this is just a flags that you have to set for the receive function. Those flags are like how many characters are uh, bundled in one packet. Then what is the sequence of those packets and all these things. These are the flag values that you have to set. But if you don't want to set any value, then what you can do is you can specify it zero as zero. It will take the by default flags. So what happens here is if you are reading the message and if the message is greater than 2000 characters, then what you will have to do is you have to keep reading it. Okay. So unless and until your read size is not zero, you keep reading this, receiving the data. Okay. So that's why we are executing this receive function in a while loop. Okay, unless and until you get the return value as zero, you keep reading. Okay, now let us say client has sent the message uh, hello server. Okay, obviously the hello server is just a few characters, it is not 2000 characters. Okay, so what is happening here, you are specifying that you at a time you can read 2000 characters, but what's happening is client has just sent around 8 to 10 characters. So when you are receiving the data, the read size, it will return the number of characters received. So server will get as a read size here as 10 and not 2000. Okay, and it is greater than zero, so that means it will still read, and there is no other message sent by the client. So next time while you are reading the next time, you'll get this value as zero. Okay, so that at that time this loop will stop. Okay, now what is happening in this program is server is resending whatever it has received. So let's say server has received hello server message. So what server is doing, it is writing the same message back to the client. Okay, so uh, it executes write function on the socket. What is the message it is writing? Whatever it is received from the client, same message will be sent back to the client. and this is just a length of the message that you are sending. Now, this also you can specify the read size, okay, because read size is exactly equal to string length of the client message. So this is what happens in this program, okay, and this is just clearing the buffers and all. You are using f flush uh, and all these things, and then you're I hope you know about the uh, allocating the memory or freeing the memory or something like that. So you are allowing this variable to use it for the next time. So I want to know if you have understood the concept of TCP socket program, server program. We haven't talked about the client program yet. Before we go to the client program, let me just have any doubts from you.
Sir, can you show the diagram of the whole thing?
Yeah.
Thank you, sir.
So we are just talking about the C program, but these socket APIs are available in all the programming languages. You you consider Python, you consider Java, consider C, C++, anything, and you can write the program in any language. You can use it in Python as well. So what would like to tell you is you just understand what is happening here, and then you can implement the similar in any other language. So shall I go to the client program? It is not uh, different than server program. Okay, so it is also taking some arguments from the command line. You are defining the only one structure here, okay, which you are sending it to the server. Now then you are defining some character variables where you are storing all the messages. Client has to execute socket function. Okay, the socket function, if you don't execute socket function, you are not uh, having a socket program itself. So that is very simple. Then you are preparing a structure. Okay, now here you are specifying the server's IP address, because client wants to communicate with the server. Now server address has to be specified over here. Now suppose you are executing the client and server on the same machine, then you can use this IP address. Okay, 127.0.0.1. It is a loopback IP address, or you can use whatever the IP address you have received from the home router. That also you can use it here. Let's say you have got 192.168 1.15 or something like that. You can specify that IP address over here. Or if you have couple of machines with you, uh, and if both of them are in the same network, what you can do is you can write the client program on one machine, and you can write the server program on another machine, and you can specify that machine's IP address over here. Okay, it will be a good practice uh, to execute the program on two different machines, client on one machine and server on another machine. And there you specify a particular server's IP address. Okay. Now, the server IP address, how you are converting, because this is just a string. Okay, 127.0. This is just a string. So that has to be converted into the data type of IP address. So this function converts the string into the IP address, inet underscore addr. Okay, which is defined in the inet.h. Uh, then the second argument is what addressing family we are using IP addressing, and what port you are using for the connection. So we are specifying the same port address which was defined in the server. Okay, so server and client are using the same port numbers. Okay, so then you are using the connect function. Okay, executing the connect function and providing the sock. What is sock here? It is the return type or socket descriptor which you have got from this socket function. The second argument is the this structure that has to be passed. Okay, so whenever you are passing this structure, okay, uh, then uh, this connect function will create a connection request. Okay, that connection request has to be first, collected by the server, and it has to be accepted by the server. So when it goes to accept function, okay, the same structure will be collected in this variable. I hope you are getting my point.
Yes, sir.
Okay, so this is sending the connection request to the server, and once it is getting the reply from the server, it will, it put, if there is any sorry, if there is any error, it returns negative value. Okay, if server doesn't is not connected, server is not reachable, server is not responding, then it sends a negative value to the connect function, and then connection fails. If there is any if there is a successful this thing connection, then you can print it connected. And you, what you are doing here, the client is getting the input from the user. So you are getting the message, scanning the message, and then you're sending that message to the server. So send function is there. So you're using sock, then you are sending the message. The third one is what is the length of the message, and the fourth one is again those flags, default flags to be set for the send. Now, how many functions we have seen for sending and receiving? So one is the send function that we have seen. It is similar to write function that was mentioned on the server side, write function. So you can also use the send function instead of write function. With both are similar functions, uh, both are similar system calls uh, with a different what you can say flavor. Uh, Another function is receive function. Okay, uh, the optional function for receive is read function, just for write, just like write. So you can use any functions as you like, uh, and then yeah, so you are receiving the message from the server, and then you are printing it. That's it, and then you are closing the socket. So this is a client program is very simple because you don't have to execute too many functions. One is the socket function, the next one is connect function, and then read write. Okay, but in the server, what you have to do is you have to start with the socket function, then use the bind function. For that bind function, you have to define the structure, then go to the listen mode using listen function. Then once there is a connection request from the client, you have to use accept function. And then once the connection is accepted, you read the message from the client and send the message to client back. Now, let me give the proper assignment to A1 and A2 and A3 and A4. A1 and A2 will send the message as I have like do the chat, like client and server are chatting with each other. So here the same message is sent by the server to client, but what you can do here is you can read the message from the client and display it on the screen, and uh, you can send some different message. Suppose the client is asking or sending the message, hi, how are you? Then server can type the message, I am fine, thank you. And that message can be sent back to the client, and that will be printed on the client's uh, screen. So simple WhatsApp you have to implement. So that will be implemented by A1 and A2 batches. A3 and A4 batch, what you can do is you can send a file. So what you have to do is um, you have to open the file and just use the file operation. So you receive the file from the client and print it on the server back. Okay. So if you have any doubts, we can discuss. I think I should not talk about the multi-threading now. It'll be too much for you for now. But if you want, I can definitely explain this. It's a very interesting concept, multi-threading. Uh, but have you gone through a multi-threading program? I hope you said no. You're not audible.
Yes, sir, we have gone through, but you can revise once again, sir.
Okay, if you have gone through, then I can
Yes,
revisit actually that part.
sir.
Okay, tell me if do you want me to explain that?
Yes, sir.
Okay, right. So for multi-threading, what happens is whenever you are creating the threads of the program, okay. So what is multi-threading? This is the parent program, okay. And whenever you are creating a thread, that thread has to perform one task, okay, and that task is defined in a thread function, okay. So that is called as thread function. So we are defining a thread function over here. So let's say connection handler. Now you can write any name for that. It doesn't matter what name you're writing. The only thing that matters is the return type, and the arguments has to be there in a void pointer type, and return type also has to be a void pointer. That is the necessary of the thread function. And whenever you are creating a thread, now first of all, why we are creating a thread? Okay, so here let's say a server wants to uh, process 3 clients at a time. Okay, if you are not creating the threads, what will happen? There is only one server program, and even if you specify 3 over here or 30 or 300 over here, even in that case, if you are not creating the threads, then at a time only one program can be one client can be handled. Okay, because there's only one program and there's only one port you are handling. So only one client can be processed at a time. But if you really want to implement this listen function to be executed for 3 different clients, then you have to create the each thread for each client. Okay, so what we are doing here, we are using pthread underscore t library. Okay, so I hope it was defined. Yeah, pthread underscore pthread header file, and pthread underscore t is the data type of the thread variable that you have to create. What we are doing here is we are allocating some space for the client variable. Now, what is client underscore sock? It is the socket descriptor that you have received from the accept function. Okay, so whenever there is a client request coming in, so that socket descriptor is defined as simple integer variable, client underscore sock. But what happens in the multi-threading environment, while you are creating a thread, you have to pass that value as a void pointer value. Okay, now remember one thing: the in multi-threading, the argument which is given to the thread function has to have a void pointer. Okay, so yeah, let me explain you what is revisit the pthread create. In the pthread create function, there are 4 arguments. So first one is the thread variable that you have created. Okay, pthread underscore t. So that is the uh, variable that you have to pass. Then if you are passing null as a second argument, then you want to uh, define a default values for the threading. So what are the default values? It might be a priority given to each thread. Then it might be a sequence in which the threads are getting executed. So there are multiple flags, there are multiple parameters that can be set by the programmer. But if you don't want to get set anything, if you want operating system to handle all those flags and all those parameters, you just specify null over here. Operating system will take care of all your threads. Okay. The third one is the function that you want to execute by each thread. Okay, so the function we have already defined over here, that is connection handler. So that we are passing it as a third argument. And the fourth argument is what are those arguments needed for this function. Okay, so the function needs one void pointer. Okay, so uh, you are passing this client's descriptor in a typecasted format, typecasted into pointer variable, void pointer. Uh, so fourth argument is the argument which has to be passed by the pthread create and which will be used by this function. Okay, so this will create a thread. Okay, and if it returns 0, then there is some problem. I'm sorry, less than a negative value, then it's some problem. Otherwise, thread will be created. Now here there are pthread join function is there. If we are sending, like distributing the job into multiple thread, then you can collect the result from multiple threads and then join the result uh, at the end. But here in this program, the client's replies are not related to each other. So we don't want to collect any data collectively. Data is not the job of this program. So we are not using pthread join here. Uh, so so this will create a thread and it will assign some job. And what is that job? So this connection handler function is written over here. It takes the socket descriptor as a uh, variable. Which socket descriptor? The client's socket descriptor. Because see, where you are passing the client sock, which you have got from the accept function, client sock is passed, uh, see, using the new sock variable, another new variable, okay, which is typecasted in a pointer variable, and then it is again retypecasted into a void variable, because it is the requirement of this function that it takes the void pointer. Okay, so this one takes the client's descriptor that you know again convert into a normal variable. Okay, see, this socket descriptor variable was typecasted twice. One was typecasted into a pointer variable from this is the integer variable. This integer variable is typecasted into an integer pointer. Okay, and then from integer pointer to a void pointer, because you have to pass it as a void pointer. Now, because it's a multi-threading requirement, now you have got void pointer. It has to be reconverted into a simple integer value, because you need to use it as a integer value. So again, it has to be retypecasted using two pointer values, integer type, and you take it into a simple integer variable. Okay. And then this function send and receive the data. So what happens is, uh, the server will create for the first client, whichever is requesting, server will create a thread which will do the job for that particular client. And at the same time, if there are multiple clients communicating, server will be creating multiple threads, and each thread will be executing for different clients, so that this listen function will be executed properly. So yeah, that's it for multi-threading. If you have any doubts, we can discuss.
Sir, can you touch on the task of batch 3 and 4?
Sorry, asked about 3 and 4. Okay, file transfer. You should, get the file, and like client will send the file to a server.
Sir, only sir one-side communication, right? Client to server.
Yeah, you can do that. So instead of scanning the message, that file has to be, sent from one a client to a server. So server should receive the file itself. See, what I want from you is you try to execute this program till the you uh, till whatever you can. If you can send a file, if you can modify the file by the server, you can resend the file back to the client. You can do anything, uh, as long as you now this multi-threading is an optional thing. The requirement is only the communication will happen between two machines, that's it. But why I have explained you this part is because I want you to work on these functions and enhance the program a bit ahead. Okay, this is not the requirement of your assignment, but still I want you to implement it. This is not compulsory, but You can do that. So this is the second last assignment in the trimester. The last assignment is UDP socket. It is more. It is very similar to TCP sockets with very minor changes. Uh, Either you can do it by yourself, or I can take another session for explaining UDP program also. But again, UDP program also uses the same functions: socket function, bind function, and all these things. With few differences, like here you'll have to use sock underscore dgram and so on. So if there are if there are no doubts, we can end this session.
Yes, sir.
Okay, fine. Uh, Let me share the attendance link. There are only 32 participants. Last time also around the participants were in 30s, but I have got the attendance for 50 students. That's a quite amazing, but let me just copy that in the sheet.